Good afternoon, class. I don't see anybody. Good afternoon, class. I don't see anybody in the chat room, but I'm going to go ahead and get started. This week we're covering two sections, 2.11 and 2.12, and both of these are focused on solving equations. And the first one is on simple equations. And we're going to talk about numerical methods that rely on numbers only to solve problems, while algebraic methods also include the use of variables. Numerical methods don't require knowledge of algebra and can be simpler, but they can only be applied to one situation. Algebraic methods become helpful as the situation grows more complicated since they organize the calculations done in the problem. So in this section we'll learn how to write and solve one-step equations to solve problems for which algebra may be preferable to numerical approaches. And on page 233 in your book, you'll see how it works, how to solve a one-step equation, and I'll let you look through that yourself. I want to mention you always want to check your answer when you're finished because it gives you a way to be sure that you've actually gotten the correct answer. So let's try some examples. Your email account states that 3.36 gigabytes, 21% of storage space has been used. How much total storage space is allotted to your email account? So first we'll do a numerical solution, and then we'll do the algebraic. So in the numerical solution, I apologize it's not showing up here, but in the numerator here I have the 3.36 gigabytes, and I'm going to divide it by 0.21, and that's going to give me 16 gigabytes. So that tells me the whole size of my account is 16 gigabytes. In other words, 21% of 16 is 3.36. And what operation was used here was division. So when we set it up algebraically, we're going to let T be the total storage, and we're going to say 21% of the total storage is 3.36. And we're going to solve it. Notice this time we're going to divide both sides, and we come up with the answer of 16, which is the same answer that we had on the prior page. And again, we use division here. Notice here we use multiplication to set the problem up, but when we solve it, we use division. And we can check our answer to make sure it's correct. Let's try another example. You're reading the newspaper and you see home value assessments. Your house is listed at $42,340. Assessments are 1/3 of the true value of the home. What is your home actually worth? Solve it numerically, so we know that this is 1/3, so if I multiply my appraisal by 3, I should get the total value of my home. And what do we use here? What operation we multiplied? So now let's do it algebraically. So V is going to be the true value of your house, and we know the true value of our house divided by 3 gives us the appraised value of $42,340. And we're going to solve the equation by multiplying both sides by 3, and we come up with a home value of $127,020. And we want to check to make sure it's correct. So $127,200 divided by 3 does get us the appraised value. Let's try another example. Only 2/3 of the class were present on Friday. If 16 students were present, how many students are in the class? Write the problem numerically. So 2/3 of the class is 16. So 1/3, which would be half of that 16, must be 8. So the total class size must be 24 students. Now let's do it algebraically. Let n be the number of students in the class. So we know 2/3 of the students in the class equals 16. Solve it. Multiply both sides by the reciprocal of 2/3, which is 3/2. So I multiply both sides by 3/2, and when I do that, I come up with 24 students. And again, we can check our answer. Replace 24, n with 24 in the original equation. 3 goes into 24 8 times. 8 times 2 is 16. Okay, the next section, 2.12, is still problem solving, but a little bit more complicated. And they also come up with a new term here called linear equation. This is an equation that can be written in this form. ax plus b equals c, where a, b, and c are real numbers and a is not 0. A linear equation is a first-degree polynomial in which the highest exponent on the variable is 1. So for instance, 15x minus 11 equals 2 and 7x equals 9 are linear equations. 7x squared equals 9 is not a linear because it has this exponent of 2 on the variable. Solve each one-step linear equation. Simplify first if that seems helpful. Okay, for the first one, I know that it tells me negative x equals 7. I need to get x by itself with a coefficient of 1. So I'm going to multiply both sides by negative 1. And so I come up with an answer of x equals negative 7. If I put that back into the original equation, the negative of negative 7 is 7, and I get a true statement. I'm going to get x by itself on b, so I'm going to multiply both sides by the reciprocal of negative 5 over 7, and the reciprocal is negative also, 7 over 5. Multiply both sides. On the left side I end up with x, and on the right side I end up with negative 63 over 5. Okay, here I want to isolate x by itself, so I'm going to subtract 15 from both sides, and I come up with x equals negative 23. And then finally, this one I want to simplify first. I'm going to change this into x plus 6 on the left side, and then I'm going to subtract 6 from both sides, and I come up with x equals 14. Solve the following equation algebraically. Okay, the first thing I want to do is move the 1. I want to get the x term by itself. That's my goal. Finally with a coefficient of 1. I'm going to subtract 1 from both sides. I have 4x equals 8. Now I'm going to divide both sides by 4, and I get x equals 2. Check. So put the x equal 2 back into the original equation. So 4 times 2 is 8, plus 1 is 9, and it checks. Solve the following equation algebraically. Alright, so the first thing I want to do is I want to get all the x terms on one side. So I'm going to go ahead and subtract 3x from both sides. I get 7 equals x, and I'm done. And I want to check, so I'm going to put 7 back into the original equation. So on the left side, I'm going to get 7 plus 21 is 28. 28 equals 28, and it checks. Okay, the next equation, I want to solve this equation here. Now, notice that there's denominators here. I want to get rid of the denominators before I try to solve it. So first thing I'm going to do is use the least common denominator to clear the fractions. And in this case, the least common denominator is 8. So I'm going to multiply each term by 8. As long as I do the multiplication of each term, of all terms in the equation, I don't change the equation. I come up with an equivalent equation. So I'm going to multiply through by 8. So I'm going to get 4x plus 2 goes into 8 4 times plus 12 equals 5x. And subtract 4x from both sides, and so I get x equals 12. And I can go ahead and check this in the original equation. See, I don't think I did it. Let's go back up here and do it. Let's go back to the original equation and check it. We'll let x equals 12. So first I have 1/2 of 12 is 6 plus 3/2, 3/2, does that equal 5/8 times 12? And if I go ahead and simplify, this will come out to be 7.5, and on this side we have 5 times 12 is 60, divided by 8, the same thing, 7.5, so it checks. Solve the following equation algebraically. Now notice we're going to have to distribute on the right side before we can collect the x terms on one side and the constants on the other side. So first thing I'm going to do is distribute. Remove the parentheses, so 2x plus 2 plus 6. Combine 6 and 2 to get 8. Subtract 2x from both sides. 2x equals 8. Divide both sides by 2. And I get x equals 4. And I can go ahead and check this back in the original equation. 4 plus 1 is 5. Times 2 is 10, plus 6 is 16. Does that equal 4 times 4, 16? And it does. Alright, there's a box in your book on page 246 on how to solve a linear equation, and this is what we're doing now. When you have a linear equation, one of three things can happen when you try to solve for x. You can get a single number for x. You can get no solution for x. And I'm going to give you an example in a minute, and that's called a contradiction, or you can get any real value for x, and that's called an identity. So one of three things can happen, and you'll see that in your My Math Lab homework. So let's try an example. Solve this equation. Okay, first thing I need to do on the left side is distribute. So I've got, I'm going to combine terms on the left side rather. So I get 3x minus 1x gives me 2x. Distribute 2x plus 2. So then I have 2x equals 2x plus 6. Subtract 2x from both sides, I get 0 equals 6. A contradiction. That means there's no value of x that I can put into the original equation as a solution. No solution. Okay, try this one. We're going to distribute on the left side, so 2x plus 2 equals 2x plus 2. At this point, you may recognize the two sides are the same. Let's keep going. Let's subtract 2x from both sides. I get 2 equals 2. This is always true. So my solution here is all real numbers, and this is called an identity. All right, so those are our problems for this week. Again, all solving equations. I don't think you'll have any trouble with the homework. I think it's pretty straightforward. Again, remember, one of three things can happen when you're solving a linear equation. You can get a false statement, which means contradiction, no solution. You can come up with a true statement, means all real numbers are the solution, or you can come up with a single value for x, or the variable that is the solution to the original equation.